Welcome! Today we're going to learn about integration of exponentials without e as the base. So first let's just review the rule. In 1 you can see that if we integrate a to the x dx, a being your base and a is a positive real number, the key here is that a is not e. It can be 3, 5, but not e. So when we integrate that, then that's equal to 1 over the natural log of a times a to the x plus c. In Rule 2, the difference between 2 and 1 is that in step 2, we have the integral of a to the u du. Now, what's the difference here? Well, the exponent is something other than x. It's going to be some kind of differentiable function of x. It could be x squared plus 2, x plus 3, anything like that. We're going to replace all of that with u. And once you do that, then you have to determine what the du is. Once you know u, you take the derivative to find your du. Once we then substitute all that back, we can integrate so long it's in this form, and we get 1 over the natural log of a times a to the u plus c. And we'll do examples to explain all this. So here's our first example. In step 1, we're integrating a to the x dx. Now this is in the form a to the x. A in this case is 8. So in step 3, I've put down the rule that we spoke about earlier, and all you're going to do is everywhere you see a, you're going to replace that with 8 in this particular case, because that's our base. So in step 4, our integral of a to the x dx winds up being 1 over natural log of 8 times a to the x plus c. And then in step 5, we just simplified a little bit more and we are done. Now, in this example, we have something that's a little more complicated. We're integrating x times 5 to the x squared dx. So this is not in the form, if it was just 5 to the x, we would apply the rule like we did in the last example. But it's not. It's 5 to the x squared. And that x squared is a differentiable function of x. And as we said earlier, we're going to replace all that with u. And when you see that in step 2, you can see I have an arrow where we've replaced x squared with u. The 5 is our a, so we have to just remember that when we apply the rule that anytime we see a, we're going to replace that with 5. But we still have to account for the x and the dx that's in our original integral. We have to replace them because we don't want to mix apples and oranges. We've got u's now, so we need everything in the form of either u or du. So what do? Well, if you go back to step 2, you'll see that u is x squared, which means or implies that du, or the derivative, is 2x dx. And that can be changed a little bit by dividing both sides by 2. We wind up with 1/2 du equal to x dx. Now, the reason we did that was because the original integral did not have a 2 in it. Okay, it just has the x dx. So that's why we divided by 2. Now, you can see that x dx is equal to 1/2 du. So we're just going to take the x dx out. We replace it with the du over 2. We replace the x squared out with u. And now we have a brand new integral. Everything in terms of u and du. So if you see step 3, that's what it looks like. And then we bring the 1/2 in front of our integral to make it nice and clean. Integral of 5 to the u du. In step 4, we are going to actually do the integration. And we're going to use the rule in 6 that we talked about earlier. So anywhere there was an a, it's now 5. Anywhere there is a u, well, the u we already had, so that part didn't really change, but we definitely want to replace the a with 5. Then in step 5, we're now going to replace the u back to x squared so that everything's in terms of x. And we are done. And that's integration of exponentials without e as the base. Now go practice, practice, and practice some more.